Hey everyone, I'm Brian Parks, and in this video I want to go through the essential Linux tips that I think every software engineer should be aware of. Now, this is not going to be a deep dive into any particular Linux distribution. This is not going to be why one is better than another. This is not even going to be how to use Linux on the desktop. This is purely from the perspective of help. I am a Windows developer, or I'm a Mac OS developer. I don't know any Linux, but for one reason or another, I need to deal with Linux either as part of my job or quickly stand something up for a side project. And that's kind of where this spun out of. One of my colleagues had zero familiarity with Linux and had to install a piece of software on a Linux VM. All we needed to do was install it on the VM and then start using it and interacting with it. We didn't need to know anything about Linux. We weren't going to be using it on an ongoing basis. And I thought I'd put together this video so that other people in a situation similar to his wouldn't have to go through the pain and headache of trying to figure out what this whole Linux thing is. Personally, I've been using Linux for over a decade and a half, basically my entire software engineering career, even though I'm a C# developer primarily, and I do use Windows. I've been using Linux for deployment, even on the desktop for a while, extensively for those at least 15 years. So again, I'm not going to go deep into any of that. I'm going to just touch the surface with the essential Linux pieces that you need to be aware of. So let's switch over to, this is actually a Ubuntu VM. I am running Windows, but this is a Ubuntu VM, and I'm running it in VirtualBox just to show this quick demo. And because this is an essential Linux, I'm not going to go into a bunch of GUI programs. We're actually going to spend most of our time in the terminal. So let me open up a terminal and let me bump up that font size for you. Let me see how I can bump up that font size for you. Let me try anyway. There we go. So because we're starting in the terminal, every command that I run, it's going to be a terminal command. Most of them will be pretty simple. And one of the things about Linux and a lot of its lineage is that more complex things are built on simpler, simple components. So even a lot of the graphical programs that you might be running in Linux, if you do have access to a graphical interface, might be running those commands under the hood. So it's really useful to know what the commands are that are actually going to be running on the system, so you can understand what's going on, even if you do eventually choose to do like a point and click sort of thing. But before we get into that, I want to talk briefly about some of the things you might hear when you get into the Linux community. One thing is the difference between free and open source software and some of the other nuances with that. So this is really a kind of a spectrum with truly free and open source on one end, and then proprietary on the other end. And there are definitely some people that have strong opinions about where on that spectrum they want their software to come from, and for good reason. I'm not going to reiterate that, so go check out, there are some YouTubers out there that have very strong opinions on that. I'll let them explain their viewpoints. But basically, on the one end of the spectrum, we have completely free and open source software. And what that means is that we're talking free as in speech, which means that you have the freedom to do with the software as you choose. Usually, that comes along with it being open source. Basically, you can't do whatever you want with the software if you don't actually have access to the source. There is a slightly more restrictive version of that, which is source available. A lot of people confuse this with truly open source. Source available really means that you can browse the source, you can download the source, but you can't necessarily make modifications to it, and maybe there are some licensing things where you can't even really redistribute the software, and that impinges on your true freedoms to use the software. There's also something in between the two, which is more generally open source. It's not truly free and open source, but it's not as restricted as source available. And those are kind of community-driven projects. So they might be, the source is available. You can go to, say, GitHub and view the source, download the source. You can even submit pull requests back to the project, but it's not truly free because you can't, via licensing restrictions, you can't do literally whatever you want with the software. So there are some nuances there. There's also, on the more proprietary end of the spectrum, there's freeware and proprietary. Proprietary is usually you have to pay for it. You can't get access to it for free. You have to go through a company, that sort of thing. And then freeware is stuff that you might actually be able to download for free. And there we're talking free as in beer, not free as in speech for freeware. And of course there are some other nuances in there, some other notches along the spectrum that I didn't cover, but those are kind of the main terms that you'll hear. Most of Linux falls on the free and open source, all the way at this end of the spectrum. It's truly free and open source. You can view the source, you can modify the source, you can contribute back to the project, and you can do whatever you want with it. Now, if you're just getting into Linux, or you just have to use Linux for a particular project, you probably don't care about any of that, but if you see those terms, that's what they mean. Now, there are also a few different major distributions, as they're called, of Linux. So you may have heard of Ubuntu, you've probably heard of Red Hat, and the two main ones are actually Debian, which Ubuntu started out as a derivative of Debian, and Red Hat. Red Hat is very popular in kind of the enterprise Linux area. So Oracle's Linux is based on Red Hat. Amazon's Linux is based on Red Hat. I think HP might have a Linux based on Red Hat. There are a bunch of others that are Red Hat based. And then kind of the more upstart group of people use Debian and Debian derivatives. So Ubuntu is a Debian derivative. There are many versions of Linux or distributions of Linux that are actually derivatives of Ubuntu, further derivatives of Ubuntu. So things like, I'm pretty sure all of these are derivatives of Ubuntu. I haven't actually used any of them, so I can't say for certain, but I believe they are. Pop! OS, Mint, Elementary, there are a few others, but they're all at least on the Debian side of the fence. Then some others that you might run into are Arch and Gentoo. Those are less popular, or less well known, less widely used. But those are also kind of, they're not based on Debian or Red Hat. They are their own distribution family. But then Arch and Gentoo have some derivatives as well. So let's get into this. Let's actually run some commands. So the first one I want to mention is ipadder. Now, you may run into some documentation that references a command called Ifconfig. Ifconfig is actually deprecated and has been for a long time. Actually, I think longer than I've been using Linux. So in Ubuntu, it's not even installed. So if I run ipadder, which gives me basically the same thing that I wanted to get from ifconfig, this gets information about the network devices on this machine and their IP addresses. So LO is the Loopback connection, or the Loopback interface. All Linux machines, we'll just say all Linux machines, you can potentially configure it without a Loopback connector, a Loopback device, but it doesn't really make any sense. This is to get back to localhost. So if you've seen the IP address 127.0.0.1 or seen the host name localhost, in Linux it goes through this special loopback device. It doesn't actually go through the device driver for the actual physical network card that's attached to the machine. Of course, this is a VM, so it's actually a virtual network card, but as far as Linux is concerned, it doesn't really care. The second one is the actual device that it will use to get out to the internet. And importantly here, you'll want to look at the IP address. So 10.0.2.15. So this will actually be important in a second, but this block also shows you some other information about the networking environment. And if you are familiar with networking and how that works, some of this other stuff might help you troubleshoot, say, if you can't connect to your Linux machine or you're trying to make outbound requests from the Linux machine, you can help troubleshoot with that. So the reason this is significant here is because most of the time, if you're not using Linux on the desktop, you're probably going to be using a program called SSH or a protocol called SSH to get to your Linux machine, which means that you need to know the IP address or the host name. And in this case, I need to know the IP address, 10.0.2.15. So this is all running on my local machine, so this is actually a virtual network because I'm running in VirtualBox. But to use SSH, my recommendation for Windows users is Putty. On Mac OS, the command line SSH program is actually installed by default on Mac OS. You're more than welcome to use that. I think there are some, I'll call them GUI graphical SSH clients, which is kind of funny because SSH is a text-based protocol, or rather the experience is a console, whether you fire up a GUI in order to get to that console or just go straight to terminal or one of the alternate terminals in Mac OS and type SSH at the command line. So in this case, we'll do 10.0.2. I think it was 15, right? 10.0.2.15. Yes. So I'll put that in the host name. Port is 22, that's the default. Now, we'll just go ahead and, 10.0.2.15. We'll save that just so we can get back to it. And there is somewhere in here, buried, there is some information on authentication. So if you're doing AWS, you have a PEM file that you have to download from AWS in order to access your EC2 instances via SSH. Now, you would put it here, except Putty uses its own format. So you'll notice when you open this up, Putty private key files. It has to be a PPK file. And the way you create that is with this Putty key generator. So you can download Putty and the Putty key generator from the web. The website isn't very fancy, but you can go ahead, download it, install it. Simple installer for Windows. But you can open that PEM file in Putty key generator, and then you can use that to create the PPK file. So there's this conversions and that sort of thing. There are also other programs that'll convert that for you as well, but that's important to know if you're connecting to AWS. So let's go ahead and open this connection. First thing it's going to do is ask me for a username, assuming it can connect. I just installed VirtualBox on this machine, so there might actually be some network oddities still. If this doesn't go through, that's fine. I'll show you on the VM. But this is how you'd use Putty. Yeah, it's not going to connect. I must have some configuration issue going on somewhere. But anyway, if we drop back to Ubuntu, we can start going through some other commands. One of the first commands you'll probably want to use is something called ls, which if you're used to Windows, dir is similar. If you do PowerShell, PowerShell actually has a command ls, and it's very similar to Linux's ls, and it just lists the directories. So bonus command pwd shows your current working directory, which in my case is home bparks. When you launch a terminal, you land in what's called your home directory, which is usually /home/your username. And in this case, I have, because I have a graphical session, Ubuntu has created desktop documents, downloads, music, pictures, stuff you might expect from a similar environment on Windows or Mac OS. A useful version of this command that I like is ls-l, and that shows, in addition to the names of the files and directories, it shows the last time they were edited, which I just installed this VM today, so this has today's date, the owner and the group, or the user and group that own the file, and permissions. And the first column indicates that it's a directory, and then this is RWX, RWX, RWX for owner, group, and everybody. So this basically says that I can read, write, and execute, which for directories that means enter. Anyone who's a member of the bparks group, which since it's a user group, it doesn't really make that much sense. There are other groups that actually do make sense to have multiple users as part of them. But this group owner can only read and enter. It can't write, which means create new files and delete files in the case of the directory. And then everybody can read and enter the directory, but they can't, again, create and delete files in that directory. So ls-l is usually what I run. There's also another one that's -al, which is all the directories, and you'll notice that some of these files and directories have a dot at the beginning of them. That's Linux's way of indicating that they're hidden. Windows, that there's actually some metadata. You right-click and go to Properties, and then you can check a box to indicate whether it's hidden. In Linux, if it starts with a dot, it's hidden. If it doesn't start with a dot, it's not hidden. And then there's another version, ls-al, which doesn't include this dot and dot dot. Dot indicates the current directory, dot dot indicates the parent directory. So ls-al, you'll notice it's the same listing as before, except it doesn't have dot and dot dot. So that's ls. The next one that's helpful is one called cat. And this is similar to the old MS-DOS or CMD program type, if you're familiar with that. Basically, it opens a file and dumps it to the console. So let's take this .bashrc file. If I do cat.bashrc, it dumps the contents of that file to the console here. This is useful if you need to see the contents of a file. If you're running into some configuration issues and you're not sure what's going on, one of the common things that people do with cat is something called cat etc issue, and that shows the version of Linux or the issue of Linux that you're running. There are some other files that give some more specific information about this other aspects of the system that you're running. But this is kind of an older version that I think is, it's not Linux specific. So if you're on another Unix machine, I started my sysadmin career on Solaris actually, and I believe even Solaris has an etc issue, but it doesn't have some of the other files that you might find in some other documentation. The next thing that's helpful is tab completion. So this isn't a specific command, but if I hit tab twice after cat/etc/, it'll ask me if it wants to show, if I want it to show all 226 possibilities. I'll say yes, and basically it shows me everything that could complete that command. And you'll see it says more at the bottom. If I hit enter, I'll go by lines. If I hit space, I go by pages, and I can hit Q to get out of that. But let's say I type ISS. I forget how to spell issue for some reason. If I hit tab, it'll tab complete because there's only one completion. So that was, I just hit tab once and it completed the file issue. Next, you notice there, when I did that tab completion, there was some paging going on. And there is actually a command in Linux that allows you to do paging. In the old days, it was called more, but now it's usually less. Of course, because less is more. I can't take credit for any of these jokes, but yes, that was why it was called less. So let's do less bash rc. When we catted that to the terminal, there was quite a bit there. So let's do less bash rc. And now we can use space to go by pages. We can use up and down arrow to go by lines. There are a couple other commands. You can search with slash and then type something, and of course pattern not found. And then to exit, you just hit Q and it drops you back to the terminal. So that one's helpful. Another useful command is something called grep, which will help you search through a file. So let's do let's go back into bash rc and let's find something good to look for. Let's say let's look for all instances of the word return. So we see one there on, what is that, the 8th line or so. So let's grep return bash rc, and we get one result. So grep by default only shows the lines that match. So it's like a filter. So basically take every line in the file and only print out the ones that match. And the order of arguments is grep, the command, and then the thing you're looking for, and then the file to search through. You can also add, I think it's -n to get the line number. And then if you want to search through a directory, you would actually do -R, I believe. And there are a couple other versions of the commands. I think -H, -H shows you the file that it appears in. So a lot of times I'll do a grep -rhn for a particular keyword and then the name of some folder. So like desktop, for instance. And of course no results, because I don't think that desktop folder has anything in it. But that's a useful command. Now the next command is copying and, well, actually two commands, but I kind of bundled them together. Copying and deleting files. So let's copy .bashrc to, let's just call it old bashrc for whatever reason. And to prove that it exists, we can ls. You can also ls a specific file and it'll show that it exists. If I do ls-l, it shows the information about that specific file. I can less it, and you can see it's exactly the same as .bashrc. Let's close that. And when I'm done with the file, I can do rm. Now there is a variant of the rm command that is, well, we'll kind of show what it does. So if I try to rm it again, obviously it doesn't exist. But if I rm-f, which is force, it just goes ahead and says, okay, sure. In this case, it's a no-op because it doesn't exist, but this is a good way to hide that output. This is force. Use -f with caution, especially if you add in -r, which is recursive. So that's how you would delete a directory that has stuff in it. Again, use this with caution. rm-rf is very, very dangerous. And rm on Linux is not like moving something to the recycle bin or to trash. it is gone. It is, remove it from the disk. You cannot get it back. Do not pass go. Do not collect $200. In fact, go directly to jail. Yeah, rm-rf is dangerous. Think before you type, watch before you type, double check before you type, or at least before you hit enter. Be careful with RM because you can do some pretty destructive things that way. Now, if you have questions about any of these commands, how can you get help? There is a command called man, short for manual pages, and let's do man rm. So this is the man page for the rm command. It gives a synopsis, so rm options and then the file, and ... means more, potentially more than one, and you get all this additional information. It does open in a pager like less, so you can use down arrow, up arrow, you can use space to go down by pages, and you can see all of the options that you can use with the rm command. Most Linux commands have a man page. Some of the newer ones, and some of the ones that aren't really like truly Linuxy, like Docker, for instance. I don't think Docker has a man page, but Docker does have Docker help. So at least there is an option that you can pass with, to the command. Whereas most Linux commands, actually rm does have a -- help. If you -help, it complains. Lots of Linux commands do a single character option is just a single dash before it. A multi-character option has 2 dashes in front of it. So if I go back to rm -- help, you'll notice some of these, -r, -R, or -- recursive. Those are all the same things. -d or --dir, same thing. One's a long form of the option, one's a short form of the option. And you can get all of this information straight from the man page. Some Linux commands, again, all Linux commands, most Linux commands have a man page. Some of them also have what's called an info page. So there's actually a command called info, and I think this will have an info page. This is one that I'm not going to mention, tar, but it has an info page similar to a man page, but it's using the info command. It's a slightly different viewer. But of course, it also has a man page, which has all the same information. So if you just remember one, remember man, because by and large, all of the Linux commands you're going to be using have a man page. Now, what if you wanted to download something from the internet? There is a command called wget, which is basically fire off an HTTP GET request to the URL you specify. And let's say www.google.com. And that's sufficient. If you just wanted to download a file, that's sufficient. It'll download it with whatever the file name is. So if you wanted to download, say, a package for a piece of software that you needed to install, you could just do wget and then the URL to the actual package download. Since this is an HTML page, I don't really want to save that. So what I'll do is I'll actually do -O for output. And of course I could specify like index.html if I wanted to save it. But instead I'm going to do a single dash, which in the case of wget specifically, there are some other commands that do this as well, but not all commands. If I specify a dash instead of a file name, it'll send it to output, to the console. And what I actually want to do is I want to pipe that with the pipe character. This is a way where you can string the output from one command to the input to another command. And I'm going to pipe that into less. So if I do that, we'll actually get the google.com homepage, which is actually some very ugly HTML there. but you can tell it is HTML. So I'll quit, hit Q to exit less. So that's wget. Now, another thing you might want to find out is what processes are running on the system. Most systems have a program called top, which shows basically the top running commands, or the most resource-intensive commands. So you can see, GNOME shell, which is the UI. Some things related to VirtualBox are some of the top highest resource-intensive processes. But you can also see things like CPU usage, the memory that's being used, so about 2 gigabytes of memory is being used. That makes sense because this VM has 2 gigabytes available to it. You can see running processes, 165 total processes, 1 running, 164 sleeping. That's not too bad. And then Q exits. But a program that I prefer is something called htop, which is not installed by default, but segues nicely into the next command that I want to describe, which is the package manager for whatever Linux you're using. So since I'm using Ubuntu, it is apt. In some cases, you might see it as apt-get. Apt in newer Ubuntus, newer Debians, newer Ubuntus is kind of a wrapper around the apt-dash family of commands. So you might see apt-get, you might see apt-cache. Apt is kind of a wrapper around all of them. So in this case, we're going to, we'll actually sudo. You'll notice that it suggests that in the command here. So it's not just going to be apt install. It's going to be sudo apt install, which sudo basically means I am an unprivileged user. I'm just my normal user, but run this command in an elevated capacity. So in Linux, basically as root. This is similar to in Windows giving administrator privileges. And on Mac OS, it's the same as running sudo. Mac OS also has sudo. Sudo apt install htop. It'll ask me for my password, not the root password. So this is actually really nice. You don't have to hand out the root password to everybody. You can just give sudo privileges. And how to configure sudo is definitely outside the scope of this video. But I'll do that. And it'll install htop. And in just a minute, I'll show you what that looks like. So that's apt and sudo. But in Red Hat land, there's yum, and I think there's actually a newer one. I haven't done much on the Red Hat side, but I should probably do some research and see what's gone on, what's new on the Red Hat side of the fence. And then Arch and Gentoo have their own package managers as well. So now that htop is installed, let's go ahead and run htop. And you can see it's a little bit prettier, a little bit more obvious what's going on here. So you've got CPU usage, which is pretty low. That's fantastic. I love to see low CPU usage. Memory is almost maxed out because, again, I only gave this VM 2 gigabytes of memory. Swap is actually a concept that exists on Windows as well, but you don't see it a whole lot. Basically, it's a file on disk that the system can use as additional memory if it runs out of actual physical memory on the system. It's not quite as fast because, again, it's on disk, but it does allow you to do some more stuff. And then the list of all the processes. And just like in top, it continues to reorder based on, in this case, CPU usage. And you can use your function keys, obviously, to get help. But F6 is really nice to change which column it's sorting by. And then you can actually kill processes. So if you have a process that is completely unresponsive, you can actually hit F9 and kill the process in question. And then F10 to quit, or Q. You should be noticing a trend. Most things, Q will quit them. All right. So moving on, you might want to see what your disk usage is like. And there are 2 commands that I like for this. One is df, which you'll notice it shows a lot of stuff, and most of this stuff is probably gibberish. So let's make it a little bit friendlier. Let's start with -h, which makes it human readable. And then let's add -l. So I usually do -lh, that's the order that I run them in. Which in this case didn't really change much because they're all actually locally, they're all local devices. But the important one is this slash here, which is the root device. So you can see this is a 9.3, it's actually a 10 gigabyte disk. Some parts of it are taken up for swap, and it looks like EFI boot, and that's about it. But you can see I'm using 2.5 gigs available, 6.4 gigs used. So that's pretty cool. So I can see, if I plan on doing anything serious with this VM, I probably want to give it a little bit more than 10 gigabytes of space. But now let's try to figure out what might be taking up all this space. The command that you would use for that is du, and I use the -sh options. So S, I forget what that means. H, again, is human readable. But in this case, I'm not going to do slash because sometimes that can take a while. On 10 gigabytes, it probably wouldn't take too long, but I want to expedite this video. So let's do dot. And that'll show that I have 8.8 megabytes being used in, again, this is my home directory. If I do pwd, I see home bparks. If I do splat, instead of just looking at the current directory, it'll look at each individual file / directory in this case the current directory, and show me that they are completely empty. 4K is just what the directory record takes up on disk. So that's where all the files would be listed and kind of linked into the directory. So something else that might be more interesting is if I do /usr, which I'll describe what that actually is in just a second here, but we get a little bit more interesting things. So we can see 3 gigabytes in user lib. Okay, that's cool. 13 megs in libexec, user libexec. 32 megabytes in user sbin. 172 megabytes in user bin. So that's cool. I'm gonna hit Control C. It finished. But if I wanted to stop it halfway through, I could have hit Control C, which actually sends that kill command. Same as in htop, if you did kill a process, it sends a command to the system and says kill this process. Control C does the same thing if you're running a command at a console. So we already talked about etc issue. Now let's ls etc. And this was pronounced Etsy before the e-commerce site Etsy, spelled differently, became popular. So this is /etc, pronounced Etsy, is where a lot of configuration goes. /etc/issue doesn't necessarily show it, but we can look through some of these things, like pam.conf is authentication related. OS release contains information about the current OS release. udev handles devices. A lot of this stuff is kind of like black magic, if you're not familiar with it. But you might have a package that you're installing, and the configuration for that will probably end up in /etc/something, either some file or some directory, and so that's what's going on there. That's what's in there. Now, we saw some things in user /usr that were interesting. Let me do echo, which echo, same on Windows. This isn't truly a command. This is actually a built-in to the shell. So let me echo my path, and you'll see a bunch of different places. This is where different executables live. So user local sbin, user local bin, user sbin, user bin, /sbin/bin, user games, okay, /user/local/games, /snap/bin. Let's focus on these guys. And first off, let's talk about the distinction between bin and sbin. You can see each one of those, they kind of come in pairs. There's an sbin and a bin. Sbin is system binaries. So things that are absolutely critical to like system administration. Some systems will actually partition those off so that root users, or the root user and administrative users, have those sbin directories in their path, whereas most normal users just have bin in their path. So things like IP might exist in sbin, and Ifconfig might exist in sbin. Maybe apt exists in sbin, but things like cat and ls, those exist in one of the bin directories, either /bin. Those commands probably exist in /bin because the expectation, especially on older systems, a lot of this stuff is a carryover from older systems because Linux is super old, and even the Unixes that came before it are even older. /bin and /sbin were guaranteed to be on the root device. /user/bin, /user/sbin, those might be on a separate device which was only mounted or included in the file system at some later part in boot. Maybe only when a user logged into the system. And then user local bin might be specific to the local machine that's being run, which might not exist on every system. So that's kind of why there are so many. You might also see /opt. Some programs might put their stuff in /opt. You can see the VirtualBox guest editions installed itself to /opt. And that's just another place. /opt stands for optional. So that's what's going on there. Yeah. So the last thing I want to leave you with is how you edit things on a system. This is probably, this is actually, if you don't care about anything else, you probably care about editing files. So a lot of times you'll see a program called nano referenced. So let's just do nano.bashrc. Nano is a text editor. It doesn't look like Visual Studio Code, but it is a text editor, and you can do kind of what you'd expect. It's intended to be fairly easy, fairly straightforward. It doesn't have a whole lot of bells and whistles, doesn't have a whole lot of frills, but as you can see, I'm using up arrow and down arrow and left and right, and it's doing reasonable things. And then down at the bottom here, you get some additional help. So the caret means control, so control G is get help, control X is exit, control O write out, or save. Control R is read a file. So let's just do control X. The most important thing you could learn about a text editor is how to exit it. So nano, it's control X. Now let's look at Vim, which isn't actually installed. Ubuntu doesn't install Vim by default, which some people might feel is a cardinal sin of Linux's, but it turns out Vim is actually a later version of a program called VI, the visual editor, which apparently is actually Vim. Yeah. Okay. So to exit Vim, you hit, if you're in normal mode, you do Control Q. If you're in insert mode, which I just hit I to get into insert mode, you hit escape to go back into normal mode, Control Q, colon Q. If you need to save, it's colon W. You can combine the commands with colon WQ. Obviously, I don't have a file there, so let's control colon Q. And let's do vi bash rc. And here you can see exactly the same files I opened up in Nano. Of course, I can I to insert and then I can use, well, I can't use up arrow and down arrow because this isn't really Vim. It's actually something called Vim Tiny, which is closer to VI than it is to Vim. But what we'll do is we'll hit escape, :Q, and then exclamation mark saying, I know it's the file is dirty, I don't want to save, I just want to quit. Don't ask me any more questions. Another editor you might be familiar with is something called Emacs. Now, Emacs is not installed on the system. And the reason, so there is a huge debate about VI over Emacs. The fact of the matter is both of them are super powerful. You can do a lot with them. Both of them have a pretty steep learning curve, at least after the initial learning curve. Emacs, I would say, has a gentler learning curve up front. VI has a bit steeper of a learning curve up front just because it has the normal mode and the insert mode, and there's actually another one called visual mode. That's pretty cool. I'm a VI user. That's where I learned. And part of the reason for that is because most Linuxes are guaranteed to have some version of VI. It might not be Vim. It might not be true VI. In this case, it's Vim Tiny. But you'll usually find something that behaves more or less like VI on the system. You can type VI in the name of a file, and you'll be in a familiar editing experience. Emacs is typically a package that isn't installed by default. So in order to use Emacs, you would actually need to install Emacs on the system. So obviously Emacs not installed here, so unfortunately we can't use that. Another final command that I'll leave you with that it might be kind of interesting. It's not really necessary to your workflow, but it's the command where. So obviously if I do where vim, it should say not found. Sorry, I'm not on Windows. Which vim gives me nothing because vim isn't installed. But if I do which vi, it shows me it's in user bin vi. Now, if we do some of the other commands that I mentioned in this video, let's do ls, it's in user bin, cat is over there, rm, user bin rm, apt, user bin apt. So which will basically show you where that command is installed. Useful, fun, I don't know if you'll necessarily run into it as you're going through your day-to-day, but good to know. And with that, we get to the end of my list. So hopefully you found this video helpful. If you want to add some commands to the list that you think are super helpful for people to know, or that, were that last command where if you had only known that how it worked, that would have gotten you through your first few experiences with Linux, go ahead and leave a comment down below. And of course, like this video if it was informative and helped you along. Share it with your friends, especially your non-Linux using friends. Show them how it's not that crazy to be using Linux for your job, or whatever job, side project. It's pretty straightforward. There's just a few commands here and there to get you going. And subscribe to the channel. I've got a bunch of videos kind of on the technical end like this, and some more conceptual, kind of helpful tips and tricks for software engineers. So go ahead and check those out. And of course, thank you for watching, and I hope to see you in the next video.